Hello everyone, myself Adarsh, and today I'm explaining the CPU implementation. In the given diagram of CPU architecture, we are using several logic gates such as A register, D register, ALU, multiplexer or MUX, and PC or program counter. Hello everyone, myself Adarsh, and today I am explaining the CPU implementation. In the given diagram of CPU architecture, we are using several logic gates such as A register, D register, ALU, MUX, and PC or program counter. So in our first step, we have to determine API for our CPU. In this, we have to specify the chip name, input and output pins, and function of our CPU. But first we are going with the abstraction of our CPU, which would consist of logic gates so that we can identify the input and output pins for our CPU. Here in our abstracted image of CPU, we can see that our CPU is taking three inputs, which are our input M, instruction, and reset. Here our CPU is taking instruction from instruction memory. Input M is the value of currently selected data memory register. Instruction is the value of currently selected instruction memory register. And reset is being used, which is our restarting signal, which will tell our CPU to restart again. Our CPU will give out write M, out M, address M, and PC. In our CPU, we can see that our ALU will give an output, which will return back to the data memory. But for this, ALU must specify the content that our CPU is going to write in data memory, which is stored in outm. The address of write operation in data memory, which is the place where we will put the content of the data memory. Now, the output, which will allow our CPU to write the content to the data memory, write M. PC will hold the address of the next instruction, which will be used by our CPU in next cycle. Now I'm going to explain the HTL code of our CPU provided in our task resources. So first we have the header section where we are specifying CPU interface, which consists of chip name, which is CPU, and its input and output pins. So first in our HTL code, input pins are 16-bit in-M, 16-bit instruction and reset, and for output pins we have out M, which is 16-bit, write M, address, which is of 15-bit, and 15-bit PC. First we are using NOT and MUX16 gate. Here in our CPU, two types of inputs are coming, which are A instruction and C instruction. In the first line, NOT gate is being used to check whether the instruction coming from instruction memory is A instruction or not. But first our CPU decodes the 16-bit instruction into an opcode and 15-bit value. If the op is 0, then instruction is A instruction, whereas if opcode is 1, then instruction is C instruction. If the instruction is A instruction, then the CPU takes the specified 15-bit value and will store the value in A register. Our A register can be fed by instruction or ALU output. If the instruction is C, then it will perform computation in ALU, and ALU out is fed to A register. For determining C instruction, we are using AND gate, and after that we will use mux16 to decide whether instruction or ALU out would be stored in A register. In the next part, we are using OR gate, which would be loaded either by A instruction or ALU output. So, if any of them is true, then load A would be 1. After that, we are using A register, which takes output A regin from mux and our load A from OR. Again, we are using mux16, which take the output of A register and in M value in data memory register. It will select A or M depending upon 12-bit instruction. After that, we will be using AND gate to determine the load bit of D register. After that, we will be using D register to load the value of D register from ALU. Now we will come to the ALU. ALU would have 6 input bits as its input, which will instruct ALU for the computation it has to perform. It will give ALU out as output. It has two output flags, ZR and NG, which will determine properties of result. Next, we will be using two OR 16 and one AND gate, which will determine whether data is to be written inside data memory or not. First, OR will determine address of write operations. Second OR gate will determine contents of data memory. And an AND gate is being used, which will output write M. Next, two AND gate are used to specify JEQ and JLT for our PC. After that, we will specify JGT using OR, NOT and AND gate. Load bits for our PC is determined by jump bits and ALU output to see if conditions are met. If our condition is C and conditions are met, then the PC is loaded with the value that will ask our CPU to jump to specified value. If PC is not loaded, then it is incremented, which means it will read next instruction. Thank you. This is the explanation of our CPU implementation.